So chapter 5 in the book, there's a lot of additional information in there that we're just not going to talk about. Instead, our focus is going to be on concentration. Reason for this is because we need to do some calculations for a lab we're going to do called Beer's Law Lab, where we're going to be taking a concentrated solution, diluting it down. So we need to kind of talk about how to do calculations with concentration. So the concentration we are going to focus on is molarity. There's some other ones out there, but that's really what we're going to be looking at. It is a capital M. It is moles of solute, which is what is being dissolved. Okay, so solute is what is being dissolved. And then the solution is actually both the solute and the solvent, okay, combo together. So if I have the unit I could use for this is a capital M, or I could use moles per liters. MOL is the substitution for that. So what you will have to do is some calculations with molar mass again. So you're going to need a periodic table and a calculator for these calculations. And there is a reason I'm picking certain compounds. For instance, this is copper sulfate pentahydrate. It is actually a blue solid, and it is what we call a hydrate because it has 5 water molecules attached to the crystal. You don't need to know that, but you will need to know how to use that in a calculation. So that's why I'm using it. There is a compound that we're going to be using. Actually, it's going to be Cobalt 2 chloride hexahydrate in a lab that we're going to do. So that's why I'm using this as our example. So if I put 125 grams of this solid into 3,400 milliliters of solution, what is the molarity? So how do I do that calculation? So first off, if I look at copper sulfate, I have this little dot between the copper sulfate formula and the 5 waters. Think of that as a plus sign. It's not a multiplication sign. So what I'm adding is 5 more water molecules in terms of its molar mass. So if you look up copper, it is, I believe it's 63.5, sulfur is 32.1, and you got 4 oxygens, which is 4 times 16. You end up with like 159.7 grams for the molar mass of just the copper sulfate. If it is a hydrate and has water attached, you're going to have to add this to the molar mass. So I have 5 water molecules, and as we've seen with previous calculations, the molar mass of oxygen is 16 plus 2 gives you 18. So this gives me an overall 249.7 grams per mole for the molar mass of this hydrate. Okay, it has water molecules attached. So the only other thing I need to remind you of is what's a milliliter? So a milliliter is 1,000. 1,000 milliliters equals 1 liter. So we will have to convert this part to liters. I cannot put that into the equation unless I convert it. So over here, what I'm going to do is take the 125 grams of my copper sulfate, and I am going to, I could set it up as a proportion. Again, it's all a personal preference of how you set it up. 249.7 grams for every 1 mole. So the number of moles comes out to be about 0.5 moles, okay, when you cross multiply this out. And so then I have to convert the 3,400 milliliters to liters. So again, it's 1,000, so I'm going to move the decimal 3 over. So it's going to be 3.4 liters. So I'm going to take 0.5 minus 3.4 liters, and I'm going to end up with 0.15 moles over liters, or I could just write a capital M. Okay, so that's the concentration if I were to dump that much into that much of the total solution. Okay, so in the second example, same calculation, I'm just changing what you are trying to figure out. Like I said, this is a solid that we are going to be using in a lab called Beer's Law Lab. So this calculation is going to be very valuable to you when we do that lab. It is a pink substance. And if I need to make a concentration of 4 molar and I need 200 mils of it, how many grams should I add to that amount of water? So all I'm doing is changing essentially back to mole. I have the molarity. I need to find the moles. I know how many liters of solution I can make up here. Okay. So what I'm going to do is I'm going to set that up. So 4 molar is equal to X moles over, and then milliliters, again, I'm going to move the decimal 3 over, so that's going to be 0.2 liters. Okay. Math-wise, I'm going to take 4 times 0.2, so I get 0.8 moles of my, that I need to make that particular concentration. So this I'm going to use instead of a proportion, I'm just going to set up the following relationship. I need to find what we call the molar mass of the cobalt chloride hexahydrate. So again, I have to add up the cobalt with 2 chlorines, and then I have to essentially add 6 water molecules to that. So again, this comes out to be about 237.8 grams per mole, again, using your periodic table, okay? So I'm going to take the 237.8 grams for every 1 mole. So if I only have 0.8, when I multiply this, I get it's around 190 grams of the cobalt chloride hexahydrate that I need to add to it. So for this, and it's going into the 200 mils of water. Well, we know that if I dump a solid into water, it is going to essentially change how much volume I have in there. So we are going to talk about how do we actually make up this solution. But before we get to that, okay, just 2 terms you're going to hear me use going forward. One is what we call a concentrated solution, and one is called a dilute solution. Now, unfortunately, I don't have like a magic number that I could give you for if it's concentrated or not concentrated. But just know that concentrated means you have a large amount of solute for a given amount of solvent, while you have a very small amount of solute if it is what we call dilute. And so in the calculations we're going to be doing, there's multiple ways of making up some of these solutions. Some you're going to start with a solid and go to and make it up, or some you're going to start with a liquid. So we're going to talk about making dilutions and some calculations associated with that in the next video.